In this tutorial, we're going to look at the meaning of decimals and their link to fractions. Then we'll have a look at rounding to decimal places and to significant figures, and then we'll take a look at irrational numbers. So decimals, what does it mean? Well, the word decimal means connected with 10. And we use the decimal number system to write all our numbers from the very smallest up to the very largest. Well, let's have a look at how that works. We use the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And those 10 digits are the only ones that we use in our number system, our decimal number system. So let's take a number. For example, 12. The 2 represents 2 units, but our 1 in this case doesn't represent 1 unit, but it stands for a 10. So what we've got here is a 2, the units, plus the 1 representing a 10. So the digits 0 to 9 are put in different places to form our numbers in our number system. Let's have a look at how our number system is constructed. Let's start with our units. There's our units. And as we move in this direction, this column represents our tens, and we've got 10 times bigger. 1 times 10 gives us the 10. As we move again, we multiply by 10 again, and we come to our hundreds column. If we continue in the same way, multiplying by 10, we get to our thousands. And again, will now be 1 followed by 4 zeros, our 10,000. Let's do a couple more. Multiply by 10 again. And this time we have 100,000. And the last one we'll look at for now, multiplying by 10 again, is our 1 followed by 6 zeros. Oh, just about squeeze them in, which is our million. Now, let's have a look what happens when we get smaller than 1. Well, what happened going in this direction? Well, if we want to go from 1 million back to 100,000, we're dividing by 10. So if we go this way, we're doing the reverse process. Instead of multiplying by 10, we're dividing by 10. Let's do that all the way down to 10 divided by 10 gives us our 1. So if we divide 1 by 10, I'm going to write it as a fraction, we get 1/10. Well, let's divide by 10 again. And this time we get 1/100th. And dividing by 10 again, we get 1,000th. And if we just complete what would happen here, if we started with 1,000th and multiplied by 10, we would get our 100th, and 100th multiplied by 10 gets us to a 10th, and 1/10 multiplied by 10 gets us to 1. Okay, let's have a look at putting some numbers in our place value system. Let's just put the chart on there. Okay, let's have a look at the number 27. Number 27 is going to be 2 in the tens column and 7 in the units. 27. 531. So we've got 5 hundreds, 3 tens, and 1 unit. What about 50? Well, 50 is 5 tens. But we can't just leave it as a 5 because that could represent, as it stands now, 5 units. We need to signify, we need to hold the place value of this 5 because it's in the tens column. So what we need to do is to put a 0 in the units column. So our 50. What about 6,000? Well, let's put 6 in the thousands. And again, we have no digits in our hundreds, our tens, or our units. But we need to put zeros in there, again, to hold the place value for this 6, so that we know it represents 6,000s. What about 207? Well, 200 goes in the hundreds column. Our 7 goes in the units column. There were no tens. So, again, to hold the place value, to make sure this 2 is in the hundreds column, we need to show that there's no tens. So 207, 207. Let's look at another one, larger number, 127,395. So the 100,000s, 127,000, so that's 2 in the 10,000s, 7 in the thousands, and 395. Let's move on to a decimal number. Let's say 6.392. Well, 6 stands for 6 units. But what do I do with the 0.392? Well, up here you can see that I've written the numbers that are smaller than a whole one as fractions. And in the decimal number system, we've got a decimal point and our 0 to 9 digits again. So I need to put my decimal point in. And that goes in there between the units and the tenths, showing that anything that comes afterwards is a part of a whole. So I'll put my point in there. And the number I had was 6.392. So the 3 is 3 tenths. The 9 is 9 hundredths. And the 2 is 2 thousandths. So the point shows us that the part coming afterwards is less than a whole one, part of a whole one. Let's have a look at 2 more on our chart. What about 0.5? Now 0.5, we can put the point in and put our 5 in. It's 5 tenths, a half. Now 0.5, I've said 0.5. 0.5 is acceptable. But it's really useful, especially when we're writing it for clarity, if we put that 0 in the units column. It's not needed strictly to hold the place value because we've got the decimal point. But to save it, getting the decimal point getting lost or not seen or seen as a smudge on the paper when it's written, then it's very useful to put that 0 in the units column. Okay, so I advise writing it as 0.5 instead of just 0.5. One more decimal, 12.027. So 12, that's our 1 in our tens, 2 in our units, a decimal point again, and 0.27. So that means we've got none in the tenths, 2 in the hundredths, and 7 in the thousandths. Now we're going to go on to have a look at some calculations. So I'll just remove this part of the chart and put another one in its place. Now, let's look at 34 multiplied by 10. Well, let's put 34 on our chart. And we're going to multiply it by 10. So our 4 is going to get 10 times bigger, be multiplied by 10, and it's going to move to the tens column. Our 3 is in the tens column at the moment. It's going to be made 10 times bigger, so it's going to become 300ths. Now, to keep our place value, we need to put a 0 in the units. That's actually come from here because we've got 0 tenths. We don't bother writing that with the number 34. We don't need to write it as 34.0, but there is a 0 here, and obviously when it becomes 10 times bigger, we need the 0 here. But we must hold the place value. So 34 times 10 gives us 340. Let's have a look at another one. This time 0.507. And this time, let's just write it here, let's multiply by 100. Well, let's have a look at this 0. If we multiply it by 10, it moves to the tens column. If we multiply it by 10 again, it would move to the hundreds column. I'll just write it in for the moment. Our 5 here, it's in the tenths column. We're going to multiply it by 100, so we're multiplying it by 10 and then another 10. So that's going to move to the tens column. The 0 here is going to be multiplied by 100, so multiplied by 10, it moves here, and 10 again, it moves to the units column. And our 7 in the thousandths column, multiplied by 10, it moves to the hundredths, multiplied by 10 again, it moves to the tenths. Let's put our decimal point in. So what we've got is an answer of 50.7. And you can see here, this is the case where we didn't really need that 0, but I wrote it in for clarity. But when we multiply by 100, we certainly don't need it because we don't say numbers as no hundreds and 50.7. So we can leave that out. Let's have a look at dividing now. Let's try 127.5 divided by 10. So let's put 127.5. Now we're going to divide by 10. So we're going to move the other way in our system. So you can start from this end or this end, it doesn't matter. I think I'll start from this end. So our 5/10, we're dividing by 10, so it's going to move to the 500ths column. Our 7 units divided by 10 becomes 7/10. Our decimal point, always in the same place, between our units and our tenths. The 2 represents tens, so let's divide by 10, and it becomes 2 units. Our hundreds, we have 100 divide by 10, and it becomes a 10. So 127.5 divided by 10 is 12.75. Now, I've put on a new sheet of paper to do some more examples, and you'll also see that I've added one more column heading here, 1 over 10,000, 1/10,000th, and that's because I'm going to need it for the next example. So let's have a look at 2.3 divided by 1,000. So let's put 2.3 on our chart, and we're going to divide it by 1,000. Well, the 1,000 is the same as 10 times 10 times 10. I have to make sure it's in a bracket here because we're dividing by the whole 1,000. So we have to do the multiplication here first before we do this division. And that's actually the same as 2.3 divided by 10 to the power 3. So we have a link here with our indices. So let's actually do that division now. Well, if we take our 3/10, divide by 10, it moves to the hundredths column. Divide by 10 again, it goes to the thousandths column. And divide by 10 again, it moves to the 10,000ths column. And our 2 in the units column, divide by 10, and again, and again, and it moves to the thousandths column. Our decimal point always stays in the same place. Now, to hold the place value of these two digits, we need to put in our zeros. We've got no hundreds and no tenths. Again, it's not essential that we put our 0 in our units, but it helps for the clarity. So our answer is 0.0023. Now let's have a look at just 2 more examples where we've used powers of 10. Let's have a look at 7.1 times 10 to the power 5. Well, here's our 7.1. Times 10 to the power 5 means that our 7 is going to be multiplied by 10 and 10 and 10. That's 3 and 10 and 10. That's 5 times. So our 7 is going to end up in the hundred thousands column. And our 1, if we multiply our 0.1, our 1/10 is going to be multiplied by 10 5 times. 1, 2, 3, 4, 5. So it ends up in the 10,000s column. Now again, everything works from our decimal point, the changeover between our units and our tenths. So we must hold the place value of this 7 and this 1. So that means we need to fill in with zeros in all these other columns. So we have an answer of 710,000. And let's have a look, 7.1 again. Let's use that. But this time we're going to multiply it by 10 to the power of -3. And that power of -3 means we're dividing. So we're going to divide by 10, divide by 10, divide by 10, 3 times. So our 1/10 is going to move 1, 2, 3 places in this direction. And our 7 will move 1, 2, 3 places in the same direction. So they end up in the thousands and the 10,000ths column. Again, decimal point there, and we need to hold the place value. So we need to put zeros in these 2 columns. And again, for clarity, a 0 in our units column. So 7.1 times 10 to the -3 is 0.0071. Okay, Let's have a look now at our link with fractions. I just need to remove these and then we can turn the page. Let's take 0.2. Well, our 0.2 is in our tenths column. So that's exactly the same as 2/10. Now let's just go a stage further with our fraction and put it in its lowest form. So that's exactly the same as 1/5. So 0.2 is 2/10, which is 1/5. So from our place value chart, we can go directly to fractions because we know that this column represents tenths. Let's have a look at 0.25. Well, our 2 again is in the tenths column, that's 2/10. But what we have in addition is 5 in the hundredths column. Well, if we add 2/10 and 5 hundredths, we put them over a common denominator of 100, and we have 25 hundredths. And if we put that in its lowest form, 25 goes into 100 4 times, so that's exactly the same as a quarter. Let's try another one. Let's take a bigger number, 134.526. So how do we turn that into a fraction? Well, our 134 is our whole number. And here, the 0.5 is 5/10. So we've got 134 plus 5/10 plus 2 hundredths plus, and the 6 is in the thousandths column, so it's plus 6 thousandths. Now, if we put these over a common denominator, we've got our 134, and our common denominator here will be 1,000, so we've actually got 526 thousandths. And again, if we put that in its lowest form, they'll actually both divide by 2, so we get 263 over 500. That was changing a decimal into a fraction. How about going the other way? How about turning a fraction into a decimal? Well, let's have a look at some examples. A half. This means we've got 1 whole 1 divided up into 2 pieces. So we do 1 divided by 2, and we get 0.5. We just carry out the division. 3/4. 3 divided by 4, and that gives us 0.75. Let's have a look at 1/3. We do 1 divided by 3, and what we find is that we get 0.33333, and so on. It goes on forever. Now, this is where you need to take care when you're using a calculator that you spot the recurring decimals, that they're going on forever. And you need to write them either then to a certain degree of accuracy, or we have a way of writing recurring decimals as 0.3, in this case, with a dot centrally over the 3. And that means 0.33333 with the 3 going on forever. Let's look now at what happens if we have a mixed fraction. So let's say we have 2 and 5/6. Well, 2 and 5/6 That's like saying we've got 2 plus 5/6. So what we're actually going to do is the 5 divided by the 6 first, and then we'll add the 2 whole ones on afterwards. 5 divided by 6 is actually 0.83333333, and the 3 keeps recurring. So we're going to write it with our dot over the 3 plus the 2. So 2 and 5/6 written as a decimal is 2.83 with the 3 recurring. Okay, that leads us nicely into doing some rounding so that we can express this sort of number, and any other number for that matter, to a certain degree of accuracy, so we don't have to write lots of decimal places. Now there's 2 ways we can do it. We can round to the number of decimal places, or we can round to a number of what we call significant figures. Let's look at decimal places first of all. Let's take an example. 32.7914. And let's say I want the answer written right to 1 decimal place, and often decimal place is abbreviated to DP. Now, the way to do this, 1 decimal place. So we just want to really chop off the rest of it, but we have to do it with a bit of care. So what I'm going to do is put a line down after the first decimal place. Now, this is where we have to be careful, because depending on what digit comes after the 7, as to whether we need to change it or not. Now let's have a look at the rules for whether we change it. If this digit is a 0, 1, 2, 3, or a 4, there'll be no change to the 7. But if it's a 5, 6, 7, 8, or a 9, then we need to change that 7. Well, let's have a look. We've got a 9, so that 7 is going to be affected. Now, why is it affected? Well, if we look at this, 7, 9 is actually closer to 32.8 than it is to 32.7. And that's why we've got these digits, the 5, 6, 7, 8 or 9, having an effect on here, because it's actually closer to the next digit up in this position. If it had been a 0, 1, 2, 3 or 4, then it would have been closer to this number being 32.7 than to 32.8. So that's why we're doing it. So in this case, to 1 decimal place, the number is 32.8. Let's have a look at some more examples now. Let's write 15.2172, and we're going to write it to 3 decimal places. Well, again, I'm going to take my line, 3 decimal places, 1, 2, 3 places, and put the line where I want to chop it off. And this is where I need to look at the digit after the line and see if it's going to affect this digit before the line. In this case, it's a 2. A 2 means there's no change. So 15.2172 written to 3 decimal places is 15.217. A couple more examples. Let's have a look at 0.315. And this one we're going to write to 2 decimal places. So I need to put my line 2 decimal places, so it's between the second and the third. And this is the digit I need to look at to see if it's going to affect this one here that comes before the line. Well, it's a 5. And here we have a 5 that says it's to be changed. So to 2 decimal places, this number will be written as 0.32. Well, you might say that actually 0.315 is exactly between 0.31 and 0.32. So why should it change? Why should it go up? Well, it is exactly in the middle. If there were any other digits here, obviously it would be closer to 0.32, so it would go up. But we have a mathematical convention, and what we say is that if it's a 5, it goes up. Because if there are any other digits, it will go up anyway. So we won't make an exception for when there aren't any other digits. We'll stick to one rule. If it's a 5 or 6, 7, 8, 9, it affects this one. So to 2 decimal places, 0.315 is 0.32. Okay, one more example, which we'll actually write to 3 different decimal places. Let's look at 6.2549. And we're going to write it to 1 decimal place, then we'll write it to 2 decimal places, and then we'll write it to 3 decimal places. So to 1 decimal place. 1 place, we put our line. This is the digit we're considering. It's a 5, so that means it will affect this 2. So to 1 decimal place, the answer is 6.3. To 2 decimal places, well, let's write the number again. To 2 decimal places, 1, 2, our line goes down. This is the digit we need to consider. This time it's a 4. That means it's going to have no effect on the digit before the line. So our answer is 6.25 to 2 decimal places. And for the 3 decimal places, let's write our number out again. This time our line goes here. And this is the digit we need to consider to see if it's going to have any effect on this digit. It's a 9, so it is. 4, 9 is going to be closer to this being a 5. So our answer to 3 decimal places is 6.255. Now let's have a look at significant figures. Now the rounding process is exactly the same as we've been doing, but it's where you start that's different. Instead of starting at the decimal point and counting decimal places, we're going to start at the leftmost non-zero digit. Let's have a look at some examples. 27.3721. And we want to write it to 3 significant figures. And we abbreviate significant figures to SF. Same process as before. So I need my line. But this time, I'm not starting here at the decimal point. I'm starting at the leftmost digit. So that's the 2 that is not 0. Still the 2. And I count 3 significant figures. 1, 2, 3. So here's my line. Again, the next digit from my line is the one I need to consider. Is it going to have an effect on this digit? Well, in this case, it's a 7, so yes, it is. It's going to change that to a 4 because it's actually closer to it being a 4. So to 3 significant figures, my answer is 27.4. Let's do some more examples. This time I have 0.005214, and I want to write it to just one significant figure. Right, one significant figure, that's one digit. I go to the left-hand end, but it must be the first non-zero digit. So this is not a significant figure. Neither's this, neither's this. Here's my first non-zero. So it's the left-handmost non-zero digit. So there's my line. I just want one significant figure. So it's this digit we look at to see if it's going to affect the digit the other side of the line. It's a 2, so it's not going to have any effect on this digit. So our answer, writing this number to one significant figure, is 0.005. Let's look at one more example, this time a big number, 27,413,200. And we're going to write this one to 2 significant figures. So, where am I going to put my line? I go to the left-hand end, the largest digit that's not 0, and I count 2. 1, 2, there's my line. So this is the digit I need to look at to see if it has any effect on this digit. It's a 4, so that means it's not going to have an effect. So to 2 significant figures, I want the 2 and the 7, but to hold the place value of the fact that this is 27 million, I need to put zeros in all the other columns. So 27,413,200 to 2 significant figures is 27 million. Now let's have a look at irrational numbers. Well, what are they? Well, let's write out the word first of all, irrational numbers. Well, irrational numbers are numbers that cannot be expressed as a fraction. A divided by B, where A and B are integers. I'll get my red pen because they cannot be expressed. They can't be written in that way. Well, what does that mean? Well, let's have a look at some examples. An example of an irrational number is pi. Now, pi, written as a decimal, is 3.1415926, and it goes on forever. It doesn't repeat in any pattern, and so it can't be expressed as a fraction. It's an irrational number. Another example is the square root of 2. If you put 2 in your calculator, press the square root button, you'll get 1.414213, and again, the numbers will continue. They'll go on forever. They won't repeat. So again, it can't be expressed as a fraction. It's an irrational number. Other examples, the square root of 3. Again, this one is 1.733 2, 0, 5, and again continues on forever with no repeating pattern. And one more example is E, and that's 2.718281, and then again continues going on forever. It doesn't terminate, and there's no repeating pattern. Now, it's worth just mentioning recurring decimals, because sometimes people think that some of our recurring decimals are irrational numbers. They're not, because, for example, 0.3 recurring goes on forever, that we write as 0.3 with our dot. In fraction form is a third. So it very much can, and in fact more accurately, be written as a fraction a over b, where a and b are integers. So recurring decimals are rational numbers, and it's these sorts of numbers where the digits don't recur in any pattern and they go on forever that are irrational numbers.